So we have one more topic concerning the weighted voting, and then we're going to go on to something completely different. Starting next time, we will talk about gerrymandering, which is a totally different topic. But one more thing about weighted voting, and that is, we talked about the Shapley-Shubik, which is one way of measuring the power of people in a weighted voting system. And I told you, I don't know if you remember, I told you when we started doing the Shapley-Shubik, actually there are two different ways to do it. One is the Shapley-Shubik, and there's another one that I want to talk about. These are two different mathematical ways of measuring power in a weighted voting system. And they work differently, and actually you get different answers between the Shapley-Shubik and this other one. I might as well say. The other one is, unfortunately, also just has somebody's name on it. This is called the Banzhaf Power Index. The Banzhaf Power Index. This is an alternative to the Shapley-Shubik. They both are meant to do the same thing, but they measure power in slightly different ways, and so you'll get slightly different answers. And it's just sort of, it's up to you to decide for yourself whether you think the Shapley-Shubik is better or the Banzhaf is better. Unfortunately, you just have to remember which is which, but actually because of what I just said about the test, we're never going to do the Shapley-Shubik again. So maybe that makes it easier to remember which is which. On our next exam, you can expect to see a question about the Banzhaf, but not about the Shapley-Shubik. So anyway, the Banzhaf, actually there's some interesting history to the Banzhaf Power Index, which I hope you won't mind if I share with you. Banzhaf is a person's name, all right? And Banzhaf was not a mathematician, was a lawyer. In the 1960s is when he kind of worked all of this out. He was living in Nassau County, which is Long Island. Anybody here from that area? Maybe some of you. I don't know anything about, but Banzhaf's whole deal was about Long Island politics, local politics in Nassau County. All right, and Banzhaf came up with this idea because he realized that his local political system was undemocratic, and I will tell you about it. So in Nassau County, there are 6 districts. This is how it worked back then in the 1960s. 6 districts in the county, and when they voted for things in the county, they voted according to their 6 districts, and they were Hempstead. This is the biggest one, and actually it's so big that it was divided into 2 districts. So there was Hempstead number 1 and Hempstead number 2. I don't know anything about these places really. And then, anyone know the next biggest district in Nassau County? No. North Hempstead. And then the next biggest one is a place called Oyster Bay. And then Glen Cove, and then the last one is Long Beach. All right, so these are the 6 districts in Banzhaf's county, and they voted. The way that it worked is you had these 6 districts, and when they needed to decide something countywide, everybody in those districts would vote. It was kind of like an electoral college system. Everybody in the district would vote, and then per district, those votes were counted up according to the populations of the districts. And so the way that these are weights, each of the districts had a weight that was according to their populations. Hempstead was the biggest, and it was divided into 2 districts of weight 31 each. The North Hempstead was weight 28, so that was slightly smaller than half of Hempstead. Oyster Bay's weight was 21, and then Glen Cove and Long Beach are very small comparatively. Their populations were 2 each, all right? And in order to pass a law or something, when they were voting on like a yes or no decision, you needed, you need just a majority of all of these, and if you add them up and do the math about how many votes you need 58 votes to win in a typical election if they're trying to decide things, all right? This is the system as it existed in the 60s in Nassau County. All right, and Banzhaf was living here and looked at the numbers here and realized. Well, anybody looking at the numbers realize anything? He said something about this is not fair. Any ideas? Yeah. Yeah, in this system here, Glen Cove and Long Beach are dummies. These values are too small to have any effect on getting to 58, right? And you can see that if you just try to think about all the different ways these numbers could add up. There's no way that these twos could have any effect here. So, and actually, it's not so obvious from looking, but it's also true. It turns out that 21 here is also a dummy. There also is no way that this 21 can influence the votes getting to 58. All right, so Banzhaf realized that the 21, the 2, and the 2 are all dummies. That is, it is impossible for those votes to have any effect on the results. All right, and this is very bad in a democracy. It's not really okay to have all of those people. That means everyone in Oyster Bay, Glen Cove, Long Beach, like they get to vote, but their vote actually has no mathematical chance of having any effect at all. So they might as well not be voting, all right? They are all dummies. That actually, if you go by populations, this is 22% of the county in terms of people. 22% of the people lived in one of those dummy districts, all right? 22% of the county who have no voting power at all, right? Like technically they are allowed to vote. They are allowed to participate in the election, but when it comes to counting, because of the way the system works, their votes cannot ever make a difference, all right? This is not okay. This is something like there was a homework question last week. In the Electoral College, are there any states that are dummies? A lot of people said, yeah, the ones with like only 3 votes are dummies. The answer is no, none of them are dummies. If any of the states in the Electoral College were actually dummies, that would be totally intolerable, and we would abolish the Electoral College or something. Because a dummy means that state has no power at all in the election, and that's not okay in a democracy. If a bunch of your people are living in dummy districts who have no power at all. Anyway, Banzhaf realized that this was a problem, and Banzhaf created his power index, what we now call the Banzhaf power index, to prove sort of mathematically a specific way of measuring and proving that his people there were all made into dummies by this system, to prove it was unfair. And Banzhaf, being a lawyer, he decided to sue the state of New York, and it took a long time for his lawsuit to work through. But in 1993, the state of New York banned weighted voting because of Banzhaf's lawsuit. So it no longer works this way in Nassau County. This was Banzhaf's great victory over the state of New York. Now, if you want to have, these people, of course, they still vote, but they don't go by districts and then add up weights. They just go like person by person. So it's as if they switch to like the popular vote rather than some kind of electoral college type system. All right, because it's not okay if some of your districts are dummies. It's also not okay if some of your districts have veto power. That's too much power. And in the real electoral college system, no state actually has veto power. That if I said, for instance, like California has veto power, what that would mean is in order to become the president, you must win the state of California, which is not true. And that would not be tolerable to the residents of the rest of the country. All right. This is, here ends the story of the interesting history of the Banzhaf Power Index. I hope that you enjoyed my story. My favorite part of the story is when Banzhaf finally won his lawsuit and they banned weighted voting. My least favorite part of the story is when all those people were dummies at the beginning. This is how they talk about stories. among little kids. Another interesting fact, fun fact, the same system actually that Banzhaf came up with, the same idea was also published at least 2 other times. The same idea was published in 1946 by a famous mathematician named Penrose. And then also done in 1971 by a guy named Coleman, who I know nothing about. And then Banzhaf first published his version of this in 1965. I wrote that the other way around. I don't know why. This can happen, and this does happen often in the history of mathematics and science more generally, is that different people have the same idea, and they all kind of claim to have invented it themselves, and they probably did come up with this each themselves on their own. It's just they didn't ever hear about the other folks. It can be a little difficult to document who actually came up with things. Banzhaf was not the first person to have this idea, but probably because of his lawsuit, he's the one who gets his name associated with it most often. All right, anyway, let's talk about how it's done. Anybody have any questions about the fascinating history of the Banzhaf power index? Probably not. It's a cute little story, I think. How do you actually do it? So it is about, the Shapley-Shubik, remember, was about putting the voters in different orders, different permutations, the perms. The Banzhaf is not about orderings. For this reason, I think I kind of personally like the Banzhaf a little bit better. I feel like the Shapley-Shubik, putting people in order, is a little bit artificial because in real life, people don't actually vote in any particular order. They all just kind of vote at once. But anyway, rather than considering orders, we consider all possible combinations of voters, not in any order, just some bunch of voters, all possible combinations of voters, I will say, not in a particular order, who can meet the quota. This ends up being also a little bit shorter than the Shapley-Shubik. You have to write down all the permutations in the Shapley-Shubik. In the Banzhaf, you have to write down a bunch of different things, but there's less of them in the Banzhaf than there are in the Shapley-Shubik. Let's just look at a particular example. How about, here's a made-up example. Ooh. All right, and as usual, I'm going to call my voters ABC. So here the quota is 16. You need to get to 16 in order to pass the election or whatever it is. All right, so we are going to consider all possible combinations of voters who can meet the quota. So I'm going to call these, they're not permutations, they are combinations. All right, the combos. What are all the possible combinations that can actually meet the quota? Well, just like writing down all the permutations, you have to have some kind of system for writing down all the combinations. And it's not so difficult. Here's how I'm going to do it. There's one combination which uses everybody, all right? If you use everybody, certainly you can make it to the quota by using everybody, all right? Or I could use only 2 at a time. So that is, I could use A and B, or I could use A and C, or I could use B and C. I'm trying to write them in some kind of a grid here, like I'm leaving sort of blank spots. That's just because it's easier for me to make sure that I'm getting all the possible combinations like this. You can use everybody together. You could use just the first 2. You could use just the last 2. You could use the first one and the last one. And then you could also only take 1 at a time. Now this is probably not going to make it to the quota, but you could just take A by itself, or just B by itself, or just C by itself. And then finally, there is one kind of technical combination which is not realistically ever going to meet the quota, but that is the combination which involves nobody, which I'll just write as like a little something like that. All right? What I've written so far is all possible ways that you could combine these voters together. I don't care about the ordering of them, just which combination there are. All right? And I want to ask myself, which of these ones actually makes it to the quota, which is 16? And that is not so hard to figure out. You just got to add up the number. So I'm going to make another column here of total weight for each of those combinations. Now, the combination A, B, C, you add all of these together, I get 12 and 10 and 5 is 27, right? And I'm just going to do that for each of these. The total weight of A and B would be 12 plus 10 is 22. A and C would be 12 plus 5, which is 17. B and C is 10 plus 5, which is 15. And then the combination of just A is just 12, just B is just 10, just C is 5, and nobody is 0. All right? These are the weights of each of the possible combinations. Are you with me so far? And what I said at the very beginning here, we consider all possible combinations who can meet the quota. So actually, some of these I don't even care about. I only care about the ones that actually make it up to 16. And so I'm going to kind of scribble out. These guys here don't even matter to us. In the Banzhaf, you only consider the ones which actually make it to the quota. And this is why it's, generally speaking, going to be shorter than doing the Shapley-Shubik, because here I only have to consider 3 different combinations rather than, say, 6 different permutations. All right? And now, this is sort of the setup. We haven't done the important step. In the Shapley-Shubik, the important step is finding the pivotal voter. In the Banzhaf, it's similar but not the same. So in each combination, we identify what we call critical voters. In this, the terminology is a little confusing maybe. In the Shapley-Shubik, it's called pivotal. In the Banzhaf, it's called critical. They don't mean exactly the same thing, which is why it's sort of slightly different words. Anyway, what a critical voter means? A voter is critical in some combination. Like in each row, you're gonna identify different critical voters in each row. A voter is critical in some combination when their weight is necessary to make it to the quota. All right, so in that example that we have up here, I kind of scrolled away from it. Maybe let me just copy. This part of the chart is the only relevant part. So let's look at the first line here. Who is critical in here? This is a little tricky. You have to look at those numbers. A, B, C, just to refresh our memory, the quota is 16 and the numbers went 12, 10, and 5, right? So when I look here, I got to ask myself, among those 3, now, altogether, they do make it to the quota. They add up to 16 or higher. Which one of them is actually really necessary? For example, is it necessary to use the A in this combination in order to get to the quota? I think the answer is yes, because if I were to take away the A, that would take away 12, in which case this only adds up to 15, and so it would not meet the quota. So here, who is critical in this combination? The answer is A is required. I will just say, the way you think this through is, if we omit A, then the weight drops to 15, which is too small. All right, so you have to kind of think about subtracting off some of them. Do you still make it to the quota even if you subtracted away the A? All right, in this case, the A is required. What about the B? Is the B necessary in order to make the quota here? Another way of asking that is, if I take away the B, does it go below the quota or is it still above? I think in this case, if I take away the B is 10, so this will go down to 17, but it's still meeting the quota. So B is not critical in this row here. A is critical B is not. Because even if you take away the B in that first line, you're still going to make it to the quota. All right? And C is not either. C is even smaller than B. So if B is not critical, then certainly the C is not. Oh, sorry. B is not critical. C is not critical. This is the little operation that you have to do when you're doing the Banzhaf. In each combination, you have to think about who in that combination was critical and who was not. Any thoughts about that? Let's just try and think through the other ones. How about in the second combination, A and B, adding up to 22? Which of them is critical? Is the A critical in that case? Show me the thumbs. I see the thumbs are going up. If that's because if you were to take away the A, it adds up to 22 with the A. But if you take away the A, that's 12 being taken away. That only adds up to 10. So A is critical. What about the B? Is the B critical? Thumbs up again, right? Because here B is worth 10. If you take away the B, it goes down to 12, which is too small. So A is critical and also B is critical. It is possible to have more than one critical. I don't know if you were thinking about that. In the Shapley-Shubik, there's always only one pivotal voter, but in the Banzhaf, you can have more than one of them can be critical. All right, so in AB, both are critical. What about in AC, which adds up to 17? I think, again, both of them are critical. The quota is 16, so if you were to get rid of either one of those, it would go down below the quota. So in AC, which is 17, A and C are both critical. All right? This is what you got to do in the Banzhaf. So can we finish? Let's just finish the calculation. We've really done all the work. Just like the Shapley-Shubik, you summarize your answers in a bunch of fractions. So I'm going to, see if I can get my, I'm going to copy this chart again, just so we can write the final answer. We've done all the work, really. I'm always, when I do the Banzhaf, I'm going to make another column where I'm going to write down in each row who is critical, A, B, or C. We decided that in the first row, A was the only critical one. In the next row, A and B were both critical, and in the last row, A and C were both critical. This is a summary of who is critical in each row, all right? And then the final answer for the Banzhaf is a bunch of fractions. So my final answer, the fractions go like this. A gets 3 out of 5, B gets 1 out of 5, C gets 1 out of 5. So the numerator is how many checks that person got, and the denominator is the total number of checks. There are 5 total checks on the chart. That's where those 5s come from. 3 of them were A's, 1 of them was B's, and 1 of them was C's. Yeah.
Can you just explain again how only the A is critical
in the first line? Yeah, this is, so what this means that only A was critical is, if I took the A away, then this would go down to 15, which is below the quota. So you need the A to make the quota in this combination. But you do not need the B. The B is worth 10, and if you took away the B here, it would go down to 17, but that still makes it to the quota.
So it's not necessarily that the like A can reach it on its own, it's just that it couldn't reach it when it wasn't there.
Yeah, that's right.
Okay.
It's vaguely like talking about veto power, although it's only among these 3. You need the A. You don't actually need the other 2 individually. And between A and B, you need the A and the B both. And between A and C, you need the A and the C both. All right, so let me just to be clear about how you get the fractions. When I write that fraction, what I say is the number of times A is critical, which in that case, in this example is 3 times because A has 3 checks in their chart. And then that's the top of the fraction, and the bottom is the total number of criticals, the total number of like checks that you put in that chart anywhere. All right. A got 3 out of 5 of them. B got 1 out of 5. And you can write these as percentages if you want. I'm not going to ask you to do this on the test, but on the homework or something, you might want to. I happen to know 1/5 is 20%, and so 3/5 is 60%. All right. So in this case, I would say B and C have equal power, and A has a lot more power than them. According to the Banzhaf, A has 3 times more power than each of B and C. All right. I don't know if you remember, but we actually did exactly this same example using the Shapley-Shubik, and I will just refresh your memory. If you look back in your notes, you will see this. The Shapley-Shubik for this one, actually we got a different answer. It was A was 4 out of 6, B is 1 out of 6, C is 1 out of 6. And as percentages, this is 66.6%, this is 16.6%, and this is 16.6%. So I'm just trying to remind you that the Shapley-Shubik answer in general will not be the same as the Banzhaf answer. Sometimes they will be the same just by coincidence, but in general, you will get a different answer when you do the Shapley-Shubik versus the Banzhaf. But they're sort of like these numbers, these percentages are different from these ones, but they're relative to one another. Their sort of overall orderings will always be the same. So in both cases, we see that B and C have the same amount of power, and A has a lot more. In the case of the Banzhaf, A has 3 times more. In the case of the Shapley-Shubik, A has 4 times more. But they both are saying B and C have the same power. All right. Any thoughts about that? So when you're doing the Banzhaf, the hard step, I mean, it's similar to the Shapley-Shubik. There isn't really anything really hard about it. It's just you have to be careful when you're doing it. The hard step, such as it is identifying who is critical. And I thought we might, I brought a fun little handout here. I'm going to do this thing first. They got those variants. My fun little handout is an example about the Electoral College. The Electoral College is like a weighted voting system, which is huge. It has basically 50 different voters in it, all of different weights. But, and we're not going to try to do the entire Banzhaf thing for the whole Electoral College, but we can look at specific combinations and ask about who is critical in this or that combination. I want to look first at the side with more stuff on it. These more recent, these are real numbers. I've looked them up myself. One more? Yeah. Let's look at the side that says 2016 and 2020 presidential elections. So let's look at 2016 first of all. U.S. presidential election. This is Trump versus Clinton, and Trump was the winner. And what you see there are all the states and how they went in terms of who they gave their electoral votes to. So Trump won all those states in the first column for a total of 306 electoral college votes, and Clinton won the second column for a total of 232 electoral college votes. I don't know if you remember. I always remember after this election, Trump said it was one of the biggest electoral college victories in the history of our nation, which is just not at all true, not even close to true. I don't know why he said that. It's not true at all. It looks like a blowout when you look at the numbers, 306 to 232, but actually this is typical of the way the electoral college goes. It's almost never really close on the electoral college total votes. But like Ronald Reagan won 49 out of 50 states, I believe, when he ran. So that was a blowout. This is not really a blowout. Anyway, what I would like to look at is, okay, so Trump won, and his combo of states added to 306, right? So there was a certain combination. I don't want to write them all down, but it's that whole first column there was his sort of combination of states, which led him to meet the quota, which is 270. I would like to look at the list here and ask us which states were critical there. Which states are critical in this combination? What you need to do is look at the states in the first column there and ask yourself, for each of those states, was this one really necessary in order to make it to 270? Or could I have done without it? So, for example, the first one is Alabama with 9 points. Was that one really necessary to make it to 270 for Trump? Or could he have still won even without it? The answer is he could have still won even without Alabama because his total was 306 and the 9 from Alabama did not make the difference. All right? So the Alabama is not critical. Are any of those critical on the list?
Texas.
Yeah, if you look closely, you will see Texas is critical because if Trump had not won Texas, that would have subtracted 38 from his total, which brings him down, I believe, to 268, right? So in this election here, Trump's combination, only Texas is critical, right? Everybody, I hope everybody sees how that goes. And this is all I really want to say about that particular election. Let's look at the right-hand side of that same page is about the Trump versus Biden election. So this is the 2020. Came down to basically the same margin in terms of the Electoral College victory. Apparently, Biden also has the greatest Electoral College victory ever. So in 2020, this time Biden was the winner, and so let's look at Biden's column there and ask ourselves which states, if any, are critical in Biden's column. So Biden's column, I meant to say Biden's combo was the winner. Are there any states in there that are critical? Yeah, California, I believe, is the only critical one in that column. All right, that means Biden actually could have done without any of those other individual states, and he still would have won, except California. He would not have won if California had gone the other way. So Biden's combo was the winner, and only California was critical. All right. This is just sort of a real-world example to make sure everybody is with it on the idea of critical. All right. Some of the in that last column there, some of the states are italic. I decided to do that. Just the italic ones are the ones which went for Trump in 2016, but switched to Biden in 2020. And there are no states that went the other way around. It's because of those states that Biden won, although not because of any one of them individually, because not any one of them, no one of them was critical except for California. All right, let's turn the page over just for fun. This is the Bush-Gore-Nader. Now, Nader didn't win any states, of course, but this is Bush versus Gore. And in the final calculation, Bush's total was 271. So this is in 2000. Bush's combo won. And who is critical in this case? Are there any critical states for Bush in this one? Yeah, I think all of them. Somebody said Texas, which definitely Texas is critical. But actually, Bush only won. He only exceeded the quota by 1 point, right? So if Bush had lost any one of those states, then he would not have made it to the quota. So Bush's combo won, and in that case, all states were critical. what that means is if any had gone to Gore, Bush would not meet the quota. All right. All the states for Bush were critical. This I suppose is kind of proof that there are no dummy states in the Electoral College, right? Because any one of those states could have changed the outcome of that election if they had gone the other way. Even, say, Alaska with 3 electoral votes, those 3 votes really mattered in that election. And if they had gone the other way, then the result would have been different. All right. That's all I wanted to say. Any questions about these? I thought we'd do a little real-world example about what it means to be critical or not critical. In a typical U.S. presidential election, there are not going to be many critical states. Usually, if the Democrat wins, then they probably needed California in order to make the quota. Usually, if the Republican wins, they needed Texas. But the small states generally are not critical, although it is, in theory, possible that they could be. It's possible they could all be. All right. Great. I wanted for you all to try an example of the Banzhaf. So, all right, I would like you all to try find the Banzhaf for this weighted voting system. 10, 6, 4, 3. All right. You got to make that whole chart like I did. You should start by writing all the possible combinations. With 3 voters, there's always going to be 8 combinations like this, although most of them are not relevant because you only care about the ones that actually add up to the quota. But all right, I'm going to walk around and see how you're doing. I hope you remember what we did. This column is just the total weight of that combination. And then in each one which actually makes it to the quota, you need to decide who was critical in that combination. See what you think.
always write the 0 thing.
No, you don't have to, because that one never makes it to the quota, so it never ends up being relevant. If you object to writing it, you don't have to. Yes or not, right? And you only consider yeah, you only have to consider the ones that actually answer. And there's several more combinations that you could do, but none of them make it. Like, all right, it looks like people are doing fine with this. Once you know, it's not all that hard to do the Banzhaf. You add up, first of all, the total weight of each column. So the first, of each row. The first one, all three of them together adds up to 13. Just A and B adds up to 10. A and C adds up to 9. B and C adds up to 7. Just A is 6. Just B is 4. Just C is 3. And nobody is 0. And remember I said you only have to consider the ones which actually make it to the quota. So actually all of these, I don't even care about those because they don't make it to the quota, which is 10. And then in each line, we decide who is critical. So between A, B, and C, adding up to 13, I say the A is critical because if I took away 6, this would go below 10. So the A is critical here. The B, I think about, what if I took away 4? Then it goes down to 9, which is below the 10. So the B is also critical. The C is not critical because the C is 3, and if I take away 3 here, it goes down to 10, which still makes it to the quota. All right, so A and B are critical, but not C in the first row. I hope that's what you got. And then in the second row, A and B add up to 10. I think they're both critical here because if I took away the A, it would not make it to 10 anymore. And if I took away the B, it would not make it to 10 anymore. So A and B are both critical in that one. I hope this is what you got. That's what I saw most of the time when I was walking around. All right, this is not my final answer. My final answer is those fractions, right? So I say A is, remember the numerator is how many checks A got, which is 2. And the denominator is how many checks there are total in the whole chart, which is 4. So A is 2 out of 4. B is 2 out of 4, which if you like percentages, this is 50%, 50%. All right. This example also we did with the Shapley-Shubik, and in that case we also got 50-50. So in this case, the Banzhaf and the Shapley-Shubik give you actually the same answer. Any questions about that? As I was walking around, it looked like everybody was doing fine. I would say, like the Shapley-Shubik, this is not really hard. It just, you have to, there are kind of a lot of chances to mess it up. But the idea is not all that difficult. All right, great. Let's talk briefly about how many combinations will there be. So with n voters, remember when we talked about this in the Shapley-Shubik? Uses actually n factorial permutations, which is a lot. Remember the factorial means if n was say 4, you do 4 times 3 times 2 times 1. That's n factorial, which is a pretty big number typically. What about the Banzhaf? I would like to know how many combinations will there be? So actually with A, B, C, there's 8 combinations. And you know, if you look at the chart that we drew here, there were 8 combinations in with 3 voters. There are 8 combinations. What if I went up to 4 voters, A, B, C, D? Actually, this on its surface looks worse than the Shapley-Shubik because the Shapley-Shubik has only 6 permutations. And 8 is more than 6. But what about, what if I went to 4? How many combinations with A, B, C, D, for example? I'm going to try and think about this. In my opinion, when we talked about permutations, I thought of it in this kind of way. It was about sort of like filling in the blanks, right? And with permutations, you fill in each of them with a B, a C, or a D. And you have four choices for the first slot. And then given that you already put one here, you have only 3 choices for the next slot, and then 2 choices here, and then you multiply those all together. What about with combinations are different though. In this case, each combination looks something like a typical combination might look like A, B, blank, D, right? That's a combination. It doesn't look like rearranging them. It just looks like in each of these 4 spots, I have to decide, is it gonna be like an A or a blank in the second spot? Is it a B or a blank in the third spot? Is it a C or a blank? So actually, in this case, when I have these 4 slots, how many choices do I have for how to fill each of the slots? I would say I have 2 choices each time. It's just, do I put the guy in there or do I leave it blank? Those are the options when I'm building a combination. So here, I will say each is either the letter or a blank, right? It's not like you have 4 different options for what you're going to put in the first position. No, the first position is either A or it's blank. The second position is either B or blank. The third is either C or blank. So anyway, the number of choices every time is just 2. It's like a yes or no for each one. Is A in there or not? Is B in there or not? All right? And so the total number of combos, what do you do with those numbers? You multiply them all together. So in this case, it would be 2 times 2 times 2 times 2. And this we would more, that as a number, it equals 16. But we more typically would write it that way, 2 to the power 4, right? That means 2 times 2 times 2, 4 times, all right? Which of course is 16, all right? So in general, for combinations, for n voters, we will have 2 to the power n combos, right? If n is 3, it's 2 to the 3, which is 8, and that's what we saw when we did that example. If n is 4, it's 2 to the 4, which is 16. 2 to the 4, by the way, is less than 4 factorial, which is 24. So actually, the Banzhaf has fewer things to write in the chart once you go past n equals 3. All right, for n voters, we're going to have 2 to the n possible combinations. I thought, just for fun, let's do one example. This is going to be kind of big, but this is the only one time in our life are we going to do this. Let's try. Maybe you'll do it on the homework also, but let's try the Banzhaf for this one here. 8, 5, 4, 3, 1. All right, with 4 voters, A, B, C, D. So, like I just said, there are 16 total combinations, which is kind of a lot, although not so much. And remember, we only have to consider the ones which actually make it up to 8. All right, so then that actually will rule out many of the different combinations. But first, let's try to write down the combinations. This can be a little tricky to make sure you got them all, but there should be 16 total if I do it properly. The first combination is you just use everybody, so that's easy enough. The next combination, so that's what you get if you use everybody. Let's also think about how could I make combinations using only 3 of them, 3 out of 4 of them. This combination that I wrote uses all 4. What if I use only 3? That's the same as saying I omit 1, so that's actually pretty easy to list also. I could say A, B, C, but not D. Or I could say A, B, and D, but not C. So these are all the ways you can do it using only 3 of them and omitting 1 of them. The last would be B, C, and D. So this is a little strategy to make sure you got them all. These ones are using 3, right? Then there's going to be a bunch which only use 2, and this is a little tricky to make sure you get them all, but using 2, I could go A, B, A, C, or A, D. Those are all the ways I could use 2 which involve A. And then I could also use two which don't involve A. That would look like BC or BD or CD. And I think that's all the ways that you can do this. Sorry, I'm off the map. This is using only two at a time is that many. And then there's a few ways using only one at a time. And those are very easy to list. It's just A, just B, just C, just D. So these are using one. And then finally there's nobody, which is using 0. All right. I know some people don't like to write the one using nobody because it never matters, and that's true. Although if you want to make sure you got them all and you're counting them up, there should be 16 of them, and that is 16 counting that stupid last one. All right, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I got them all. All right, this is how you write down all the combinations of 4 things. All right, and we have to go through each row here and decide who is critical. That sounds like a lot of work, but it's not going to be so bad because most of these don't even make it to the quota. So can we write down the totals here, the total weights? Remember what A is 5, B is 4, C is 3, D is 1. So in the first line, the total weight is 5 plus 4 plus 3 plus 1, which is 13. In the next line, A, B, and C, you add up, I got 12. A plus B plus D would be 10. A, C, and D is 9. B, C, and D is 8. Right? I hope you don't mind me adding all these numbers in my head. You can probably add numbers just as well as I can. I got a scroll too. All right, those are the totals. Next, these ones, if I take just 2 at a time, A and B makes 9. A and C makes 8. A and D is 6. B and C is 7. B and D is 5. C and D is 4. Actually, I think from here on, they're all going to be too small, right? I'm only going to consider the ones that make it to the quota, which is 8. So these ones, just taking one at a time, for example, is never going to make it up to 8. So really, the point at which we need to consider is only here. These guys are not going to matter because they don't make it to the quota of 8. All right? So really, this is the chart that we need to consider. Maybe I'll let you guys finish this one off. See if you can decide in each row who is critical. The A, the B, the C, the D. I'll give you a few moments. See what you think. In any given line, it could be they're all critical. It could be none of them are critical. Remember, if they add up to exactly 8, that still counts as making it to the quota. said in the first row that nobody is critical.
Is that the only row where no one's Yeah, there should be one thing. Because you could do
Yeah, right. So in this combination, you need to be more than instead. All right. All right, can we talk about it? I don't know if everybody's finished. In the first, like I said before, in the first line, actually, nobody is critical. That's because if I look at, like, take A, for example, A has 5 points. They all, total is 13. If I were to do without the A, it would drop down by 5, and then the total would only be 8. But 8 still meets the quota here. That means this A is not necessary to make it to the quota in this line. The B, the C, the D also, they are not necessary for the same reason. Those are even lesser point values. So there should be no one critical in the first row. What about the second row? They add up to 12, and you ask yourself which of these three is actually necessary in order to make it to 12. I believe the 8 is necessary because if I took away 5, this goes down to 7, which is too low. So the A is critical here. The B is not critical though because the B is worth 4. If I take 4 away here, it goes down to 8, which is still making the quota. So the B and the C here are not critical. And certainly the D is not, because the D is not even part of this. All right? I hope that's what you got for the first 2 rows. It is easy to make individual little mistakes when you're doing this, in my opinion. So don't. I don't know. I don't have any great advice. Just be careful and try not to mess it up. How about this one? A, B, and D. They add up to 10. If I were to take away the A, I lose 5, so this would go below 8. So A is critical here. If I take away the B, I lose 4, which makes it go down to 6. So B is critical. And if I take away the D, that goes down by 1, which is still 9, which is still making the quota. So D is not critical in this line, just A and B. I hope everyone agrees. What did you get for A, C, and D? Someone want to shout it out? Yeah, A and C, I think I agree. A and C are critical here. D is not, because D is worth only 1 point. If you got rid of the D, you still make the quota. So A and C. And B, C, and D adds up to 8. If you took away any one of those, it would no longer make it to 8. And so they are all critical in this one. All meaning B, C, and D. Not A, of course, because A is not part of that. In the next one, A and B add up to 9. But if I took either one away, it would not add up to 9 anymore. So they are both critical. And then A and C adding to 8, they are also both critical. So this is what I got for all of my check marks. I hope you got something like that. Any questions about any of those? It is a little confusing, I suppose, and easy to mess it up. Anyway, what's my final answer then? I count them all up. So A has 5 total check marks. And the denominator here will be the total number of checks, which you just have to count up. There's 5, 6, 7, 8, 9, 10, 11, 12. So this is 5 out of 12 for A. B gets 3 out of 12. C gets 3 out of 12. And D, 1 out of 12. All right? This is my final answer for the Banzhaf. Any questions about that?
So when you're writing the answer, you don't say like A is the Banzhaf winner. You just give all the next years.
Yes. Yeah, actually, I saw this a few times on the test. When you were all doing the Shapley-Shubik on the test, first of all, basically everybody did it perfectly in terms of the numbers. Some people said, therefore A is the winner or something. This is not what you should say. The point of this is not to figure out, like, A wins. That's not what this is about. The Banzhaf is meant to measure the different ratios of power that each of these are like 4 different people in a weighted voting system. And the results are that A has this much power, B has this much power. We're not trying to choose one of them as like the king of Long Island or something like that. All right? Great. One last thing to say about this, and then maybe I'll start saying a few words about gerrymandering. One last thing to say about this is, what about dictators and dummies? This probably you would think of on your own naturally, but in a weighted voting system, let's say like if X is a dictator, if one of your voters is actually a dictator, that means their vote is already greater than the quota, and that automatically means everybody else is a dummy. Then their Banzhaf score will be 100%. That's because if one of them is a dictator, that means they will be critical every time, because in order to make it to the quota, you need to have the dictator on board. So that means they will be critical every time, and it also means nobody else can be critical, because if there is a dictator, then everybody else is a dummy, and the dummies could never be critical. Their votes are never necessary in order to make it to the quota. And so if X is a dictator, that means all the critical votes go to this one person, which means their Banzhaf score as a fraction will be, 7/7 or something like that, or as a percentage it would be 100%. And if X is a dummy, they will never be critical, and so when you write their fraction, it's 0 divided by whatever. And a fraction with the 0 on the numerator is equal to 0. As a percentage, 0%. So if X is a dummy, they're never critical, so their Banzhaf is 0%. All right? And this is what Banzhaf did in his court case. He said, here's how you measure who is powerful in this system. And then he showed that Oyster Bay ends up with a 0 because there is no combination in which Oyster Bay is critical. All right. And this is all I want to say about the Banzhaf. Any more thoughts or questions about the Banzhaf? All right. And actually, that's the end of weighted voting. That's what we've been talking about for several weeks now, and it's over. I was hoping to put that on the test so in our first test so that we could be like completely done with it, but didn't quite make the cut. That means there will probably be one question on your next test about the Banzhaf, and then the whole rest of the test will be about something completely different. All right, so remember this. I predict you will forget how to do the Banzhaf by the time our next test comes around. You will refresh your memory before the test. All right, any more thoughts about that? All right, in our remaining 9 minutes, I want to give you a little sort of introduction to gerrymandering. This is our next big topic. Gerrymandering. This is actually still on the general topic of voting, although it's going to be very different. The kinds of things, kinds of homework questions that we do about gerrymandering are very different. This is very much a hot topic these days in our world. One of my daughters is into hot topic. That's not what I meant, though. She's not into gerrymandering, but she likes the graphic tees. But anyway, gerrymandering is a big deal in our society today. There are a lot of people who think that, the United States is drifting into fascism, and the reason is gerrymandering. There are people who blame all of our society's problems on gerrymandering. I'm not quite there yet, although it is, in my opinion, important. I don't know if it's apocalyptic the way that some people describe it, but what it's about, it sounds totally boring, but it's about the arrangement of districts when voting. And I want to just, for today, I'll just tell you in vague terms a real-world example. Usually when people talk about gerrymandering, they talk about it in the context of elections within the states. So this gerrymandering has nothing to do with the presidential election. Gerrymandering is not a factor in electing the president. It is a factor in electing, it's also not in electing senators, because you just get 2 senators from every state, and they are not elected from arranged districts. Arrangements, I mean like the geometry of the shapes of the districts that you use. This is what gerrymandering is about. Arrangements of districts when voting. For example, the great state of Connecticut has 5 U.S. Congress districts. In the state of Connecticut, there are, because of our population, we get 5 Congress, U.S. Congress representatives, and it goes according to populations. The smallest states only get 1. The biggest state, like California, gets something like 51, I think. Anyway, Connecticut, because of our population, we get 5 U.S. Congress districts. And the way that it works when you vote for your congressperson, as we will do in a few weeks, I don't know if you vote in the state of Connecticut. I vote in the state of Connecticut. You don't vote for all 5, though. You only vote for the one whose district you live in. And the districts in Connecticut, Connecticut is shaped something like this. The districts vaguely, I'm going to bring like a real map of this next time, but they vaguely look like this. And the numbers these are just the district numbers. We live in Connecticut district number 4. Anybody happen to know who our U.S. congressman is in this district? It is Mr. Jim Himes. I don't know much about Jim Himes. I follow him on Twitter. He has bees. He makes honey. Yeah. Mr. Jim Himes is a Democrat. Connecticut has 5 U.S. Congress districts like this, and that means we get to elect 5 Congress people, but like when I vote, my choice, I don't get to vote on all 5. My choice is Jim Himes or whoever. I don't follow the election too closely. I don't even know the other one that Himes is running against. Anyway, if you look at the voter demographics in Connecticut as a whole, so in the state of Connecticut as a whole, if you look at the breakdown in terms of who is a Democrat and who is a Republican in terms of voter registrations, the Democrat versus Republican split is about, I believe it's about like 65%, 35% in favor of the Democrats. Connecticut is well known as a reliably Democratic state. It's been quite some time since a Republican for president won the state of Connecticut. It's something like 65-35 in terms of the Democrats. Now, given that we have 5 different Congress people and about 35% of the state are Republicans, how would you expect the split for these 5 districts to go? So our U.S. Congress districts, I will say, according to the demographics of our states, our U.S. Congress representatives should go, now there's 5 total, so it can't exactly agree with this breakdown, but I would say it should go maybe 3-2 or maybe 4-1, right? This would be Democrats, Republicans, right? Just because the state has 35% Republicans and there are 5 representatives, you would expect maybe 4 of them would be Democrats, 1 Republican, or maybe 3-2. Anybody happen to know what the actual breakdown is of Congress people from the state of Connecticut? In terms of how many, there are 5 of them. How many are Republicans and Democrats? The answer is, in the state of Connecticut, it's 5-0. The Republicans get nothing, even though they represent 35% of the population of the state. That should at least get you 1 out of 5, right? In fact, it does not. They get 0 out of 5. All D's. All right? Why is that? Why is it that they don't even get 1? Is that unfair somehow? I mean, from this statistical point of view, I would say, yeah, it is unfair. That big portion of our population in this state has basically no representation in the Congress. At least they didn't get to pick any. Anybody have some idea? Like, why would that be? Why would that be true? Yeah. Yes, she said it perfectly. Because this 35% is somehow spread around, so that in each district they're never able to win any of those districts. This is because those 35% are spread around throughout the districts. All right. It is a fact. If you drew these lines differently, you could draw the lines in a way which actually packs a bunch of Republicans into the same district, and then they would be able to win one of them. Maybe it would be more fair if the lines were going in a different direction. You might ask yourself, the fact that the lines go the way they do, is that some kind of scam by the Democrats to prevent the Republicans from winning any of these? The answer to all of these questions is, well, maybe it is a scam by the Democrats. This is what gerrymandering is all about. The arrangements of the districts, precisely where you draw the line. These lines here actually makes a huge difference. So that's what we're going to talk about. This is really about geometry. Very different from the other stuff that we've been doing so far. All right. I hope that sounds interesting. See you next time. No quiz next time, and no homework due tomorrow.